Hey everyone, welcome back. In the last video, we learned how to interact with Git using some handy shortcuts. In this video, we'll talk about the most common ways to revert changes in Git and when to use each approach. Let's get started. Being able to revert our changes is one of the most powerful features offered by version control systems. There's a bunch of different techniques available depending on which changes we need to undo. For example, you might find yourself in a situation where you've made a bunch of changes to a file, but decide that you don't want to keep them. You can change a file back to its earlier committed state by using the git checkout command followed by the name of the file you want to revert. Speaking of, let's try this out using our scripts repository. We'll edit our all-checks.py script and remove the check reboot function, then save and go back to the command line. We've made our change. Let's try our script and see what happens. As expected, we see that our file is modified and the changes aren't staged yet. Check out how Git gives us a couple helpful tips on what to do now. We can run git add to stage our changes, or we can run git checkout to discard them. Let's do that now. We'll check out the original file, and then take a look at what git status has to say about it, and finally retry our script. Looks like we have a typo. Let's go back and fix it. Done and done. With that, we've demonstrated how we can use git checkout to revert changes to modify files before they get staged. This command will restore the file to the latest storage snapshot, which can be either committed or staged. So if you've made additional changes to a file after you've staged it, you can restore the file to the earlier stage version. If you need to check out individual changes instead of the whole file, you can do that using the -p flag. This will ask you change by change if you want to go back to the previous snapshot or not. That's it for undoing unstaged changes. What if you added the changes to the staging area already? If we realize we've added something to the staging area that we didn't actually want to commit, we can unstage our changes by using the git reset command. Staging changes that we don't actually intend to commit happens all the time, especially if we use a command like git add star, where the star is a file glob pattern used in bash that expands to all files. This command will end up adding any change done in the working tree to the staging area. While sometimes that might be what we want, it can also lead to some surprises. Let's try it out with an example. First, we'll pretend we're trying to debug a problem in our script. For that, we create a temporary file with the output of our script. Then, we'll add all unstaged changes in our working tree using git add star. Finally, check the status using git status. We can see that this output file, which was supposed to be a temporary file for debugging, has now been staged in our repo, but we didn't want to commit it. Conveniently, the git status command tells us how to unstage the file right there in the output. The example output mentions the head alias. Remember what that means? That's right. It's the current checked out snapshot. So by running the suggested command, we're resetting our changes to whatever's in the current snapshot. Let's try it out. The file is once again untracked in our working tree and no longer staged. You can think of reset as the counterpart to add. With add, you can add changes to the staging area. With reset, you remove changes from the staging area. You can use git reset -p to get Git to ask you which specific changes you want to reset. Get it? But wait, let's remember to commit our typo fix. With that, we've seen how we can revert unstaged and staged changes. But what if you've already created a commit with the changes that you want to undo? Let's say you just finished committing your latest batch of work, but you've forgotten to add a file that belongs to the same change. You want to update the commit to include that change. We can solve problems like these using the -- amend option of the git commit command. When we run git commit -- amend, Git will take whatever is currently in our staging area and run the git commit workflow to overwrite the previous commit. Let's see this in an example. We'll go to our scripts directory and create 2 new files using the touch command. then list the contents of the directory using ls at our Python script, and commit it saying that we've added 2 files. As you can see, the message printed by Git says that only 1 file was added. Our commit message said that we added 2 files, but we forgot to add one of them. We can fix it. We'll start by adding the missing file and then amending our commit. We called git commit -- amend, and an editor opened up showing the commit message and the stats about the commit that we're working with. The list of added files for this commit now includes both files that we wanted to add. Yay! Now that the files have been added, we can also improve our initial commit message, which was a bit too short. We'll keep the existing description as the first sentence of our commit, and then add a line of description about the intended purpose of each file. With that, our commit is ready to be amended. Let's save a new description as usual. We've amended our previous commit to include both files and a better message. You could also just update the message of the previous commit by running the git commit -- amend command with no changes in the staging area. An important heads up, while git -- amend is okay for fixing up local commits, you shouldn't use it on public commits, meaning those that have been pushed to a public or shared repository. This is because using -- amend rewrites the Git history, removing the previous commit and replacing it with the amended one. This can lead to some confusing situations when working with other people and should definitely be avoided. So remember, fixing up a local commit with amend is great, and you can push it to a shared repository after you fixed it. But you should avoid amending commits that have already been made public. Fixing your work before you commit is good. But what happens if it's already been snapshot by Git? Let's say you host a Git repository on a company server that contains all kinds of useful automation scripts that you and your coworkers use. One morning before coffee, you make a few changes to one of these scripts and commit the updated files. A few hours later, you start to receive tickets from users indicating some part of the script is broken. From the errors they describe, it sounds like the problem is related to your recent changes. You could look at the code you updated to see if you can spot the bug. But more tickets are pouring in, and you want to fix the problem as fast as possible. You decided it's time for a rollback. There are a few ways to roll back commits in Git. For now, we'll focus on using the git revert command. Git revert doesn't just mean undo. Instead, it creates a commit that contains the inverse of all the changes made in the bad commit in order to cancel them out. For example, if a particular line was added in the bad commit, then in the reverted commit, the same line will be deleted. This way you get the effect of having undone the changes, but the history of the commits in the project remains consistent, leaving a record of exactly what happened. So git revert will create a new commit that is the opposite of everything in the given commit. We can revert the latest commit by using the head alias that we mentioned before. Since we can think of head as a pointer to the snapshot of your current commit, when we pass head to the revert command, we tell Git to rewind that current commit. To check this out, we'll first add a faulty commit to our example repo. We've added some code to our script. Let's save and commit this. Let's run our script to see what happens. Oops, we used a function that we forgot to define. Okay, it's rollback time. Let's get rid of this faulty code by typing git revert head. So once we issue that git revert command, we're presented with the text editor commit interface that we've all seen before. In this case, we can see that Git has automatically added some text to the command, indicating it's a rollback. The first line mentions that it's reverting the commit we just did called add call to disk full function. The extra description even includes the identifier of the commit that got reverted. While we could use this description as is, it's usually a good idea to add an explanation of why we're doing the rollback. Remember that the goal of these descriptions is to help our future selves understand why things happen. In this case, we'll explain that the reason for the rollback is that the code was calling a function that wasn't defined. Once we're done entering the description, we can exit and save as usual. You'll notice the output that we get from the git revert command looks like the output of the git commit command. This is because git revert creates a commit for us. Since a revert is a normal commit, we can see both the commit and the reverted commit in the log. Let's look at the last two entries in the log using -p and -2 as parameters. As demonstrated before, the -p parameter lets us see the patch created by the commit, while the -2 parameter limits the output to the last two entries. So in this log, we can see that when we called revert, Git created a new commit that's the inverse of the previous one. This removes the lines that we added in the previous commit. We can see that the original commit shows the lines we added by preceding them with a plus sign. The same line shows up with a minus sign in the newer commit message indicating that they were removed. Just like that, the bad commit is reverted and the error stopped. In this example, we reverted the latest commit in our tree. But what if we had to revert a commit that was done before that? In our bad snapshot example, the error also happened to be in the most recently created commit, but errors can sometimes take a while to be detected. And so, we might need to revert other commits farther back in time. We can target a specific commit by using its commit ID. We've seen commit IDs a few times already. They show up when we're running the git log command, and we also saw the commit ID of the reverted commit in our last example. Commit IDs are those complicated-looking strings that appear after the word commit in the log messages. Let's have a look at the latest log entry in our checks repo. The commit ID is the 40-character long string after the word commit. You really can't miss it. This long jumble of letters and numbers is actually something called a hash, which is calculated using an algorithm called SHA-1. Essentially, what this algorithm does is take a bunch of data as input and produce a 40-character string from the data as the output. In the case of Git, the input is all information related to the commit, and the 40-character string is the commit ID. How can you use commit IDs to specify a particular commit to work with, like during a rollback? Let's look at the last two entries in our repo using the git log -2 command. First, let's look at that specific commit using git show, which we mentioned earlier this video. We've copied and pasted the commit ID that we wanted to display, and that works. Alternatively, we could provide just the first few characters identifying the commit to the command, and Git will be smart enough to guess which commit ID starts with those characters. Let's try this out. 2 characters is not enough, but usually 4 to 8 characters will be plenty. All right, now we've managed to identify a commit. Well done. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we will talk about branching and merging. Thanks for watching, and see you soon.